now I would request Mr. Akilur Rahman, CTO ABB India, to now please deliver the special address. Ladies and gentlemen, Mr. Akilur Rahman.
Good morning all. It's a privilege to be here and honor to be speaking to the experts, the policymakers, the leaders in the world of renewables, water distribution, and also the technology adaptation in these areas. um, Coming to these two areas, renewables, water distribution, it has been a very conventional way of handling these, and it has been there for decades. So, how do we move to the next step, next phase? How do we address the future? So, I am going to talk about some of the technologies, automation, digitalization, how we can write the future of renewables and water distribution getting into the mainstreaming. If you look at today, the utilities, industries, infrastructure, transport, so what are the trends? Trends from the point of view of technologies, disruption, and also the new challenges. If you look at utilities, so we have more and more shift to the renewables happening. That's why we are here today also talking about renewables. Making the grid digital, energy internet, so how do we transact, how do we manage, how do we optimize energy using internet. When it comes to industries where the utilities are feeding power, the energy to the industries, there we have the new trends of industrial 4.0, or you can say industrial IoT, fourth industrial revolution. Collaborative manufacturing, flexible manufacturing, real-time optimization of the production, the industrial production. And coming to the infrastructure transport, we have smart cities, especially in India and also in other parts of the world, including the smart energy, smart water, smart environment, smart buildings, smart roads, infrastructure. Electric mobility, which is also shaping up very fast, having the electric vehicles in the city space, in the rural urban areas also, and also providing mobility as a service. So, these are the trends which are there in the present situation. And if you see the common denominator for all these trends and technologies, the disruption in a positive way, which is digitalization. Right from the utilities, getting the power, energy, feeding into the industry, doing the industrial production, optimizing them and managing the infrastructure, making them smarter, including the water distribution, including the energy distribution, and also addressing the transport. Before I get into the very complex situation of the systems, let me tell you the digitalization, what is it, how it has evolved, and why we are doing it. So, a simple example of a motor, how we have digitalized it. You know, when it started as electromechanical equipment where the data was kept in a book, notebook or file with papers, and then we moved to keeping the data, maintaining the data about the motor, the design, the operating parameters, the maintenance records on PC servers. So, today we have motors where we are putting smart sensors on top of the motor. Not to open the motor, but just putting on top of the motor without stopping the motor. And this smart sensor can collect the data in real time, the operational parameters, the data about the motor, vibration, temperature, electrical parameters, and taking it to the cloud so that we have the real time data available about the motor, not only the motor, also the application areas of the motor where it is used. It can be used in a water distribution network, for example, for pumping. So, why we are doing it? So, Of course, the technologies they have enabled us, whether it is cloud computation or maybe smart sensors, inexpensive computing environments, but there is a reason why we are doing it. It's all about improving the key performance indicators of that particular asset or maybe system, if it is a water network or a power plant. So here we are getting very tangible benefits out of this digitalization. We can reduce the downtime of the motor by 70%. Downtime of the motor also leads to downtime of the process, the system. So that way we can reduce the downtime of the operation. We extend the life of the motor, life of the system by 30%. We also improve the energy by 10%. So these are the quantitatively achievable benefits of digitalization. I think this is what we are looking for, whether it's a motor or it's another equipment or system or automation system in renewable or in water distribution. So this is what we are looking for. Similarly, transformer is another example of digitalization, where it used to be again electromechanical, electromagnetic equipment. So we have put the sensors in that, and we are monitoring the parameters of the transformer, the operational parameters. By that we are able to predict failures, by that we are able to extend the life of the transformer, by that we are able to improve the availability, reliability of the system, and quantitatively reducing the downtime, improving the efficiency in the system, reducing maintenance cost, extending the life of the transformer. So these are examples of assets in our system, whether it's renewable or water or any network, where we can take advantage of automation, digitalization to improve the performance. Coming to a very complex example, this can be a industrial plant, or it can be also water network, SCADA, PLC. So where we have a lot of different types of sensors, actuators, controllers. So they have been there for several decades. We have been operating them as control systems, distributed control systems, closed loop control systems. And they connect different type of machines, equipment, devices. They control the process, they optimize the process, of course intranet, it's a plant or system network. But today what we are doing is we are extending these systems with putting the sensors, taking the data to the cloud, so that this data can be viewed by several stakeholders, not only the plant operator owners, but also experts. Experts from the industry, experts from the academia, experts from other domain which is related to this area. They can combine the data coming from other sources which is impacting the operation of this particular system. It can be renewable system or water systems. Take the data, weather forecast data, take the market data, take the user behavior, consumption data, and then optimize and improve the key performance indicators of the system. And here it's also providing us opportunity to use new technologies, digital technologies, whether it is user experience or analytics or artificial intelligence, machine learning, virtual reality, augmented reality. So these are the technologies which are driving the automation system today, and we are getting added benefits of automation, optimization, and this is also leading to a path where we can continuously improve the performance of any system, whether it's a renewable system or water network or system. Not going into the details, the technologies as I talked about, virtual reality, augmented reality, how they can be used, machine learning, artificial intelligence. So the algorithm to optimize a particular operation of a system or device can also be made automatic by having artificial intelligence. The algorithm will change by itself, having the data coming from the device, from the operations. Big data analytics, that's the talk of the day. So here we have huge amount of data available from the machines, from the processes. We're talking about using sensors, smart sensors. We are using inexpensive computing environment where the computational, the operational optimization can happen on the edge on the device. And we also are going to use the communication technologies. For example, 5G is going to come in future. Blockchain is another area where it can be used for energy transaction, where in future it's not only the big players who will be the producers of the energy, but also the consumers who can produce energy having the rooftop solar, for example, and when they are not at home, they can sell the power to the neighbors or to the grid. So these technologies driving the digitalization, and which can be very much used for renewables for the water. And very important aspect here in the automation and digitalization is health, like human being, asset health index, which is basically developed. Each asset, each system can have model which can be based on its design. It can be on the operation of the asset of the system, using the data from the SCADA PLC, using the data from online sensors, for example, the smart sensor I talked about. So taking all the data, we can build a model of that particular asset in a specific situation, in a specific system. And this model also can be converted to a machine learning algorithm, artificial intelligence also. And here we are doing again this to achieve predictive maintenance, prescriptive maintenance of the system, improve the availability of the asset of the operation, detect the anomalies in the system, predict the failures, and of course rank the failures and provide priorities, and make the spare parts available so that they can be quickly brought to the system without any delay. So when it comes to renewable, it's not just the having the renewables, it also has to be integrated with distributed sources of energy. And this will help us to also connect the islands, utilities in the islands where we have the microgrids. They can be connected to the grid, they can work standalone, they can also work along with the grid. Remote communities where they can have, they don't have the access to the transmission line, the remote, the microgrid can be set up there. It can be also used in industrial environment, commercial environment, urban communities. So basically, working standalone as at the same time also connected to the grid. So you have the advantage of both. So this is how the renewables in future is going to shape up the energy ecosystem with storing the renewable energy and managing the energy with microgrid, working standalone as well as with the grid in an optimized way. So this will also lead to digital power distribution. So once we have the renewables integrated, whether it is solar or wind, and you also have the fossil fuel, the conventional energy sources. So they can be integrated into the system so that the grid, the distribution system can be managed, can be made available with nil, almost zero downtime, and you can also have platform to improve the operation of the system further. So here you can see that it integrates all different type of sources of energy, all different types of loads, including the electric vehicles, chargers, including different renewables like solar and wind. And this data, this platform is available for several experts to analyze and also contribute in improving the system. So coming to electric vehicles, electric mobility. So here we have now chargers, electric chargers, vehicle chargers available, which are not traditionally, taking 8 hours, but also let's say in 8 minutes it can charge the car for 200 kilometers. So fast, ultra fast chargers. So they have to be connected to the system. They can also use the renewable energy. So here we need ecosystem which is already there, where these chargers can be optimally placed in a city, and they can be also operating in a way that they don't destabilize the grid, because they really extract lot of suck lot of power, huge amount of power, surge power from the system. And at the same time they also provide user experience in terms of information, real time information to the drivers to find the location of the charging station and also charging time and also doing the transaction. So finally, it's also how these different type of systems, whether it is digital distribution system or different sources of energy, they can be connected and they can be forming a virtual power pool. So by this, we will have more energy available with high availability and efficiency for consumption for management. So coming to the water network, so we have of course in water networks a lot of different equipments sensing the water flow, the leakage, and also monitoring the consumption point with smart meters. Here again we are also using the sensors to take the data in parallel to the cloud and make it available for different experts, different stakeholders to analyze, to optimize the water management, the consumption, and also minimize the leakage. So here again we are using different technologies, the digital technologies, AI, ML, uh, analytics, process analytics, data analytics, and of course the virtual reality, augmented reality. So this digital automation and digitalization has also helped us to have the real-time data available. So real-time data available right from the global level. So for a distributed system having different plants and operations, having the KPIs, having the indication in real time, getting into the details where exactly something has happened, some failure has happened, or some prediction is providing us to maintain a particular equipment. It can get into the details of a particular system, whether it's a motor connected to a compressor or pump, and how the motor has failed, why it has failed. You can also compare it with its digital twin, the model, the software replica of the equipment, and also with asset health model. So this is all about how we can monitor different parameters, different machines, but for different contexts. And so it can be forecasting, it can be also the energy, it can be productivity, it can be quality, asset health. So all these things can be monitored, can be optimized in different levels, not only in the system plant level, but also in the enterprise level. So when we talk about artificial intelligence, machine learning, I think all these machines we are using, they also can be taught. Today we are teaching them, these machines, what to do, what actions to take, for example, this robot. But we are also working on machines which will learn by itself by observing the system and operation. And in future, it is not only just the artificial intelligence, the artificial learning which will be useful, but also the human and artificial. I think both intelligence, they have to be augmented to get the benefit of the optimization of the system. So with this, as you see that moving from copper and iron, we have built electronics, we have automated the operation, but in future, I think we are moving towards autonomous operation through the digital technologies and having the cyber physical system. So the message is that in renewables, in water distribution, making them smarter, I think we have the automation technologies there. We have the sensors, we have the communication technologies. We are now moving towards digitalization, and there is also platform available to make them autonomous. And this is what I just wanted to say. Thank you very much for listening.